Welcome back to the channel. In this video, we will be dealing with periodic classification PYQs, and the PYQs are from 2008 to 2014. I have noticed in 2015 and 16 the questions from periodic classification were not asked, and after 2017 I'll be having one more video. This is part 1 of chapter wise PYQs. So we will see the chapter periodic classification. So let's begin with 2008. The first question is an element with atomic number 21. So by 21, it is a concept based question. 21, if you see scandium, it is a D block element, and a D block element or also called as transition element. This is one way you can find out by concept based. One more way to find out is to write the electronic configuration. So 21 means we have argon 18. Next we have argon 18, we have 4s2, 3d1. 18 plus 2 we have 20, 20 plus 1 is 21. So it is a D block. To find out which block it is, you have to see the last electron filling to a D block element. So as a D block element also called as transition element. So answer is 3. Next question is the correct order in which first ionization potential increase. Now what is ionization potential? Energy required to remove an electron from the outermost shell. So if it is a smaller size, then energy required is more. If it is a bigger size, energy required is less. The correct order first ionization is we have sodium, potassium and beryllium. And ionization energy, if you see, along the period it increases and down the group it decreases. And if there is any fully or half-filled electronic configuration, then the ionization energy is more. We have beryllium, this is first group and this is second group. Beryllium, sodium and potassium. We have sodium here and potassium here. Along the period it increases. So first comes beryllium will have larger ionization energy, and down the group it decreases. Second is sodium and third is potassium. So the answer is beryllium, sodium and potassium. Answer is 2. Next is 2009 paper. Just see the correct order of ionization energy. Again, ionization is energy required to remove an outermost electron. Valence electron specific. Energy required to remove valence electron. We have carbon, nitrogen, oxygen and fluorine. All are second period. This is second period element. It is carbon, nitrogen, oxygen, fluorine, all are P block element. If you see the electronic configuration, we have carbon as 2p2, p3, p4 and p5. Along the period, we know ionization energy increases. Why? Size decreases, Z effective increases, and that's the energy required. As size increases, the nucleus and the electron pulling will be, force of attraction will be more, due to which to remove electron it will be difficult. So we have to put more energy to remove these outermost electron. If you see the order, if you go with this trend, the order is carbon, fluorine will have highest highest ionization energy, followed by oxygen, nitrogen, carbon. This is not true. Here there is a change. Nitrogen is half-filled configuration, and half-filled configuration is more stable and requires more energy to remove electron than that of oxygen. So the correct order is fluorine, next comes nitrogen, oxygen, then carbon. So order is carbon, oxygen, nitrogen, fluorine. So option is second. One more question in 2009 we have from periodic classification. They have asked 1, 2 and 3 questions. So let's see the next question. The oxides of element whose electronic configuration is 3s1. Before that, in periodic table, if you see the periodic table, this is S block, then we have D block, then we have P block. When you move towards the right side of periodic table, the acidic strength increases, and towards the left side or down the group, the basic nature increases. And if you see 1s2, 2s2, 2p6, 3s1, the calculation now which this configuration belongs to which element can be found out where electron is filled last. Electron is filled in S orbital, so it belongs to S block. this is S block. So we know towards left side it is basic and towards right side it is acidic. So this configuration of this element belongs to S block and it is basic in nature. So answer is 1. Next question, characteristic not related to alkali metal. This can be dealt in periodic classification chapter. Also it can be dealt in S block element. Let's see what it is. Characteristic which does not belong to alkali metal. Alkali metal, it is nothing but group 1 element, or it belongs to S block element. If you see alkali metal down the group, atomic size increases. Also, if you see along the period, Z effective increases. Z effective is tendency of a nucleon to attract the electron is more. Why? And due to that, size decreases. If size decreases, more number of energy is required to remove these electrons. That is, ionization energy increases. Ionization energy increases. Where? If you move from left to right of the periodic table. Also, electronegativity also increases. What is electronegativity? Tendency to attract electron. Why electronegativity increases? Because Z effective increases. So if you see all this information, and also if the size decreases, that means from left to right we need more melting point. So melting point also increases from left to right when we move along the period. So keeping all this characteristic, let's see what all are there in alkali metal. Alkali metal we have towards the left side of the periodic table. Does it have low melting point? Yes, it is right. It has low electronegativity. Yes, it's true. It has high ionization energy. This is wrong, because from left to right the ionization energy increases. Why? As Z effective increases and size decreases. Z effective is nothing but force of attraction of nucleus, or also called as effective nuclear charge. Let's see, their ions are isoelectric with noble gas, nothing but if you see the cations, alkali metal, they have NS1 configuration. I'll take example lithium. Let's take example. Lithium has atomic number 3. It has 1s2, 2s1. If you see lithium plus Li plus, so you'll remove one electron, it will be 1s2. It will be which configuration? Noble gas configuration, duplet configuration. If I add one electron, it will be 1s2, 2s2, fully filled configuration. Again, it is an noble gas, helium configuration. So if you make it a cation, or if you make it an anion, it will be isoelectronic. Isoelectronic is element that has same number of electrons. Or anion, if you make, the number of electron will be same as that of noble gas. What are the noble gases? We have, there's no space. Noble gases are right here: helium, neon, argon, krypton, xenon, and we have radon. All these are fully filled electron. These are inert, they don't form in bonding, and they are called as noble gas configuration. This is of 2009 question paper. Let's see 2010 question paper. Generally, the first ionization energy increases along the period. That is true. We have seen along the period, if you move, ionization energy increases. Yes, but there are some exceptions. Yes, there are some exceptions. What are those exceptions? If you see carbon, nitrogen, oxygen, fluorine, what we think along the period it increases. This will be the order, but it is not true. The exact order is this. This is not true. The exact order is carbon, fluorine, after that nitrogen, oxygen, then carbon. Why? Here electronic configuration. Similarly, it holds good for phosphorus and sulfur, or similarly this holds phosphorus, sulfur. Or if you see beryllium has fully filled 2s2, and boron. If you see second period, we have lithium, beryllium, boron, carbon. Here also, what do we think? This is the order, but this is not the right order. Why? This is not the right order because it has fully filled electron. Ionization energy is more. So correct order will be lithium. Next comes beryllium, requires more energy than that of boron. Why? Fully filled electron, 2s2 configuration. So this is about few exception cases, but there are some exception. One which is not exception we have to see. Okay, we have sodium and magnesium. First, let's see where all this element placed in the periodic table. We have sodium and magnesium, third period. Welcome. First, let's write all this element based on how it is set in periodic table. We have sodium and magnesium, that is in third period. Sodium and magnesium. Next is beryllium, which is above magnesium. After beryllium we have boron, then carbon here, nitrogen, oxygen, magnesium, here we have aluminium. Okay, along the period we know ionization energy increases, but there is exception also that we have covered here, which is not an exception. Let's say sodium and magnesium, along the period it increases, there is no exception. Here there will be changes, that is aluminium comes later. Here there is an exception. We have, see, the ionization order for this period is sodium, then comes aluminium, then magnesium. Okay, so there's no change in the exception. This is the right option. Beryllium, boron, they do have exception. Why? First, beryllium has more energy, required more energy than boron. Nitrogen, oxygen, they do have, because nitrogen have half filled configuration. Magnesium, aluminum also they do have. Why? Magnesium has fully filled electronic configuration. So only that doesn't have is sodium and magnesium, and along the period ionization energy increases, so they have simple trend here, but here it changes, it will be like this order. So this is of 2010 a previous year question. Next, 2011, let's see. Generally the first, here this question has been repeated. This question has been repeated when the options have been changed, similar to that of 2010 question. Just previously we have dealt with this. The option is first one. The correct electronegativity order of nitrogen, oxygen, fluorine and phosphorus. Electronegativity. What is electronegativity? Tendency to attract shared pair of electron. How much a nucleus has tendency to attract the electrons. The order of electronegativity is along the period. If you move from left to right in the period, the electronegativity increases, and down the group electronegativity order decreases. And if you see here the elements that they have given, nitrogen, carbon, nitrogen, oxygen, fluorine, and we have nitrogen, below nitrogen we have phosphorus. Along the period electronegativity increases, so fluorine has highest electronegative, then is oxygen, then is nitrogen, and down the group it decreases, then comes phosphorus. So correct order is third option. The correct order of ionization, as I explained earlier. So if you notice one thing, most of the time the questions have been asked from ionization energy. So people, no matter in NEET, KCET or Maharashtra set exam, the tendency to ask from ionization energies, probability of tendency to ask questions from ionization energy is quite more than that of other topics of periodic property. Again, tendency to attract ionization energy is energy required to remove an electron from outermost shell. If you see the trend along the period, ionization energy increases, down the group it decreases. You have carbon, nitrogen, oxygen, fluorine. Here we have P3 configuration, so it requires more energy. To remove these electrons. So order is fluorine as highest, then comes nitrogen, then oxygen, then carbon. So we have this option in third option. Next, let's see 2013 question. A quite interesting question is this, a new question. Which of the following set of ions represent the collection of isoelectronic species? So what is the meaning of isoelectronic species? Iso means same. Electron means electronic means electron. So species are same number of electron. No matter how is the number of atoms, how is the number of protons. Let's say same number of electron. We have potassium. Let's see all the atomic number. What is atomic number? That has same number of proton, or it can also be denoted as same number of electron in neutral atom, not ions, neutral atom. So let's see let's see number of electron. In potassium we have 19, chlorine we have 17, magnesium we have 12. So they have given potassium plus, so it will be order is remove one electron, it will be 18. Here chlorine minus, we will add one electron, it will be 18. Okay, these are the same electronic species. Mg2 plus, remove 2, it will be 10. So electrons are different. This option is deleted. Next we have again here potassium. Let's see second option. Sodium has atomic number 11. Na plus is given, so removal of one electron will be 10. Calcium atomic number or number of electron is 20. 2 plus is given, it will be 18. Again this option is eliminated. Next third option, this is an option elimination method. K plus has atomic number 19. Plus is given, so removal of one electron, it will be 18. Calcium 2 plus, calcium has atomic number 20 electrons, it has removal of 2, it will be 18. Okay, these two are right. Scandium has 21 atomic number, removal of 3 electron will be 18. Again, these are also a set of electronic configuration. And last one is chlorine has atomic number 17, it has 17 electron, removal minus anion will add electron, it will be 18. So all have 18 electron, that means this set is electronic species. So correct option is 3. Let's see 2014 question. 2014 paper, they have 3 questions that has been asked, 2 questions that have been asked, a quite interesting questions. The correct arrangement of ions in the increasing order of the atom radius. Okay, increasing order of their radius. Calcium, if you see, most of them are isoelectronic species. Isoelectronic species is same number of electron. And there is a trick for isoelectronic species, that is atomic size is inversely proportional to Z. This is the trick for isoelectronic species only. Z is nothing but atomic number or number of protons. So as Z increases, atomic size decreases. So let's see calcium atomic number is 20, potassium atomic number is 19, and sulfur, it has atomic number 16. Atomic number 16. Okay. Along the, if you see the correct order, how it goes, increasing order of correct order of the ion in the increasing order of the atomic radius. If you see calcium, if you see calcium, K2 plus is given, so it will be 18 electron. K plus again 18 electron. Sulfur 2 minus, you will add, all has 18 electron. So if you see as atomic size and Z, as Z, if you see this proportion, as atomic number increases, atomic size decreases. So if you see, this is the atomic number. Calcium has highest atomic number, it must have least atomic size according to this proportionality. So calcium will have least atomic size, next comes potassium, and next comes sulfur. So the correct option is 1. This is the trick for this question. Isoelectronic species, atomic size is inversely proportional to Z, atomic number. Next question. This is an interesting question. Among the elements from atomic number 1 to 36, the number of elements which have unpaired electron in the S subshell. So S subshell, it can fill up to 2 electrons, we know that. So they have asked unpaired electron, that means that has electronic configuration 1s1. Sorry, not 1s1, ns1. Before that, they were given atomic number 1 to 36. Let's see how to approach this question. First write inert gases: helium, neon, electronic atomic number 1, neon 10, argon 18, and krypton we have 36. So, and the one electronic 2, sorry, helium has 2, hydrogen has atomic number 1. So from 1 to 36, this is first period. second period, third period and fourth period. Helium, after hydrogen we have lithium, sodium and potassium. 1, 2, 3 and 4. These all are group 1 elements and they have configuration ns1. So we have 4 elements that have electronic, this is not 1 2 3 4. We have hydrogen, lithium, sodium and potassium. Hydrogen has 1 atomic number, 3, 11, potassium has 19, and then we will have krypton 36. Here it ends. These all belong to group 1 configuration. These all belong to group 1 configuration, group 1, and they have electronic configuration ns1 and they all have unpaired electrons. So answer would be 4 elements, but this is wrong because in between this we have d block elements, and in d block element we have chromium 24 that has electronic configuration 4s1 3d5. Also we have copper 29 that has configuration 4s1 3d10. So these are also group element that has unpaired s subshell electron. So total is s block element 4, and from d block element, that is in between 1 to 36 we have 2. So total 4 plus 2 we have 6 elements like that. So answer is fourth one. And from 2015 and 2016 paper there were no questions that has been asked from periodic table. Hope you have understood each and every concept. If you have any doubt, please comment down in the comment section. And from 2017 to 2025 I will be doing a next chapter wise video in the upcoming days. Thank you.